All right, 6.6. One more for today. All right, so again, warm up. Simplify the polynomials by multiplying everything on inside this by everything inside this, right? X times x is x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. 4 times 4, 4 times a negative 4 is negative 16. Combine your like terms. These cancel. You're left with x squared minus 16. (25) m squared minus 5m plus 5m minus 1. Cancel your inverse, your opposites. 2m squared minus 1. For a squared negative 6ab, ab, alphabetical, plus 6ab. And if you remember to write them alphabetical, you'll be able to recognize immediately when you have inverse, when they cancel each other out. If they were out of order, you wouldn't know they canceled each other out. Negative 9b squared, 4a squared minus 9b squared. Notice something interesting? The resulting product is called the difference of squares. Everything in here is something squared. X squared is x times x. Negative 16 is 4 times 4. Get it? They're all something squared. They're all something squared. This should be 25. How do I know? Because 2 is not something squared. 5 times 5 is 25. Should be 25. 25 is something squared. It's 5 squared. They're all something squared. You can use this knowledge if you know your squares, right? To factor a difference of squares. First, make sure you have an actual difference of squares. Right? It has to be perfect squares. It can't be almost perfect squares. It has to be perfect squares. Right? Second, use the following rule to factor. You'll do a plus b times a minus b. Every time. Every time. Every time. Check your work by distributing. We didn't do that on the previous one. We should probably have done that. Alright, factor each difference of squares. Check your work by distributing. If a polynomial cannot be factored, write prime. Get used to seeing your perfect squares. Right? Remember what they said. If they're perfect squares, it's going to be, right, it's going to be a plus b times a minus b, right? A, b. A plus b, a minus b. The variable is x, so it's going to have an x plus and an x minus. The square root of 81 is 9. 9 times 9, right? Bam, bam. I just showed you 2 different ways to do it without even thinking about it. Find the perfect squares. Alright? It's going to be k this time. One of them is going to be plus, one of them is going to be minus. 25 is 5 squared.
Teachers and students, pardon this interruption. Mr. McMillan, you need to be on control. Mr. McMillan.
9 is 3 squared. B is our variable. One of them is going to be plus, one of them is going to be minus. 10, the square root of 100 is 10. 10 times 10 is 100. All you're doing is breaking it into squares. All you're doing is breaking it into squares. 4a plus, 4a minus. 121 is what? 11 times 11? Square, 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 square. As long as it's all square, it's not prime. 2h plus 5g and 2h minus 5g. They're copies of each other. One positive, one negative. They're copies. Copies of each other. Alright? X, y plus 1 times x, y minus 1. It's really that simple. 2c plus 5d, 2c minus 5d. Square, square. Ah, they almost got me. I'm going back and asking myself, is this a square? Is this a square? Is this a square? Is this a square? This is not a square. That is not a perfect square. Which means this is probably prime. 15. Prime. Bam. They tried to get us. But because I went back and asked, is everything squared? I can tell you that's not a difference of squares. It's prime. They have nothing in common. Nothing. Nothing to be factored out. You almost got me. K to the 6th and 16ths. In order for it to be 6, I think we need it to be something squared. So k to the 3rd plus 4 and k to the 3rd minus 4. Because when you multiply this, you're going to add them together. 3 and 3 is 6. That's interesting. 121 R6 minus 1. So we know it's 11. We know it's R cubed. We know it's plus and minus 1. Right? Yes. Alright, look for a greatest common factor first, then factor the remaining difference of squares. We're combining the last two units. Right? So first we're going to look for a greatest common factor. Both of these can be divided by 2. I'm left with n squared minus 36. Is n squared and 36 perfect squares? Yes. Right? So then it becomes 2n plus 6 and minus 6. Right? Yep. Alright, so first I factored out the 2, and then I found the difference of squares. Oh, they're making us do both. Alright, greatest common factor. Is there a common factor? Both can be divided by 2. If we take 2 out, if we factor 2 out, I'm left with 16s squared minus 9u squared. And these are perfect squares, and these are perfect squares. So I'm left with 2 4s plus 3u times 4s minus 3u. Perfect square, perfect square, perfect square, perfect square. Greatest common factor, no variables in common. Both can be divided by 6. Both can be divided by 6, so let's see what happens. If I take a 6 out, I get 4a squared minus 9b squared. Squared, 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 squared. So now it's 6, 4a plus 3b times 4a minus 3b. Greatest common factor. 5? No. They both have n's. They both have an n squared. So 5n squared. If I take 5n squared out of both, 80 divided by 5 is 13? No? 16? I think it's 16. That leaves me with 16n squared, which is a perfect square. 125 divided by 5. Let's see, 20, 25. 25. And I canceled this one, right? Because I divided by 5n squared. Perfect square, perfect square, perfect square. So now we have 5n squared, 4n plus 5, 4n minus 5. Right? 16 squared, 4 times 4 is 16, n times n is n squared, 5 times negative 5 is negative 25. Because they're perfect squares, I can break them down. 2 more. We got this. All right. They both have at least one p. Both can be divided by 9. So let's divide by 9p. If I divide by 9p, I'm left with 4p squared minus 1. Squared, squared, squared. 1 is a perfect square because 1 times 1 is 1. 1 squared is 1. So that leaves us with 9p times 4p plus 1, 4p minus 1. These both have a k, and they can be both divided by 4. Let's do 4k. So if I take out 4k, I'm left with 4k squared minus 25. All squares. So 4k times 4k plus 5, 4k minus 5. Just like that. Just like that. All right.